This is Nanoscape. I'm Seth Zimmerman.
And I'm Erin Spain.
On this show, we venture into the frontier of nanotechnology
with experts in the field who are turning the science of small into the next industrial revolution.
This podcast is brought to you by the International Institute for Nanotechnology at Northwestern University.
Today, we are excited to chat with Dr. Omar Farha, a top chemist whose pioneering work in metal organic frameworks known as MOFs is pushing the boundaries of what's possible in nanotechnology and critical industrial sectors such as energy, environmental sustainability, and national defense.
Omar is the Charles E. and Emma H. Morrison Professor in Chemistry here at Northwestern and the new chair of the Northwestern University Department of Chemistry. He is also an entrepreneur, co-founder of NewMat, a company based in Chicago that has grown into a leader in the field of precision chemistries.
NewMat is the first company in the world to industrialize MOFs across many important sectors. Today, we are going to talk about Omar's research and get a primer on what makes MOFs so special and find out what he's most excited about for the future of nanotechnology. Please welcome Omar.
Thank you for having me and looking forward to sharing what I know about my field and what we do with you and the IAN audience.
Let's start at the very beginning. Let's talk about your journey into the fields of chemistry, material science, and nanotechnology. What drew you to this type of work?
Listen, I am an immigrant, came to this country to study here. So I came at the age of 17, went to a community college in Southern California. So I'm a community college product. That tells you don't need to go to Harvard and Caltech and MIT or even Northwestern to be a professor at Northwestern.
But you should.
But you should come to Northwestern, obviously, but you don't have to. But that also says about the culture of Northwestern. That means they don't recruit from very specific, backgrounds. And that's what drew me to Northwestern. But then I went to UCLA after, my community college, and I came to Northwestern here for my postdoctoral training, and I've been here since then as a faculty member. What drew me into chemistry is really the ability to be able to make new things that nobody else before me or my group could make them. In particular, I was interested in materials for medicine, for environmental, for energy. So what I did for my PhD is completely different than what I'm doing right now, except they have one thing in common. What I did for my PhD is three-dimensional molecules. So you could look at them. They have the three-dimensionality like a soccer ball in a way. And now I make materials that has the three-dimensionality, and they called metal organic frameworks. And we'll talk about this in a little bit, obviously.
As we mentioned, you lead pioneering work in metal organic frameworks, MOFs, as we call them, which you have described as sophisticated bath sponges or bath sponges on steroids, and a class of materials that could be called nano tinker toys. Could you explain what makes MOFs so unique and powerful?
Yes, absolutely. I love the description, and that's why I always use programmable sponges, because we all can visualize what a bath sponge or what a kitchen sponge looks like. Except a bath sponge or a kitchen sponge, whatever you spill, you could wipe it and it doesn't discriminate. You could wipe a Diet Coke, you could wipe a regular Coke, or you could wipe your mimosa if you spill it early in the morning. It does not care. Versus, if you come to the sponges we make, that's why we call them smart and programmable, because we could make them and we could tailor them in a way that they will be specific for specific tasks. If we want them to pull a specific impurity from water, we could program them to do that way. If we want to pull a toxic gas from air, such as carbon dioxide, we could do that. If we want to capture a nerve agent and detoxify it, we could do that as well. So we have the ability to do that. And we have the ability because we have so many options to choose from. We are building on a whole periodic table. If you think about how many metals in a periodic table, so there is many of those. Organics, we are standing on the shoulder of organic chemists that made organic molecules for the last hundreds of years. So now, theoretically, on a computer, you could think that we could build millions of these different sponges. And now, we could actually pick the right sponge for the right application because we could use computer simulation and data science before we even go to the lab and make them. And the future is how can we use machine learning to be able to predict before my students and postdocs go to the lab and make these materials.
So are these sponges we'll be expecting to find on our shelves at the local pharmacy anytime soon, or is this something a bit larger than that?
Like everything else, I always use the Tesla. A few years ago, how many Teslas you saw on the road? Very few, because you had to pay $150,000 to get a Tesla that you could drive for 150 miles. Right now, you could get a Tesla for $40,000 that can get you to 150 miles. So for the metal organic frameworks, Numat, for the last 10 years, is able to commercialize these materials. Started in the electronic industry because it's low volume, high value market. Then we went into the defense market, and now it's much larger market, and we're going more and more toward larger and larger markets. It's almost, I would say, in 15 years, 20 years from now, I would not be surprised that you will see MOFs in many applications, and regular people, they might actually interact with MOFs without knowing that they interacted with MOFs. I would not be surprised if you bought an iPhone or an iPad or some electronic gadget in the last year or so. It's possible that MOFs were involved in the process of the doping those wafers to make the chips that went into those electronics, because that Numat's first market. So maybe you haven't seen that MOFs is in your phone or in your gadget, but it was used to be able to make your phone and your iPad and your computer function better in a safer way for the people work in those environments.
You mentioned a couple different industries, electronics. You also mentioned energy and national defense, environment. I'm wondering, how do you choose which industries you're going to work with? What guides your research?
Absolutely. Sometimes when you have a platform technology, and MOFs is a platform technology, what I mean by that, it's the similar materials, but you could use them in unlimited applications. Then how do you choose your applications? The first thing, when you start a new company or a new field, you have to go into areas that if you could solve a problem, it will change people's life. If you solve a problem, people would care. If you solve a problem, people would buy it. And that's how you get a start. It just making a product for the sake of making a product and hoping somebody will come and buy it from you. Hope is not really a solution to anything. You have to have conviction that what you made, if you actually get to make it, somebody will care about it. So let's differentiate my work at Northwestern versus my work at Numat. Northwestern, I am an academic. I want to go after fundamental studies and come up with answers to questions that nobody has the answer to, because we are at the IAN at Northwestern University Chemistry Department. We are typically at the forefront of science. We are not following. My colleagues are leading science and what science can do for humanity. And that's how we think about it. So in my group at Northwestern, it's really the umbrella is energy and environment together. Everything under energy and environment, that's what we work on. But those two things, they are connected in so many different ways. For example, being able to capture toxic chemicals easily without a huge energy penalty, that's energy related, because you don't have to make more electricity and generate more CO2 making those electricity, but at the same time, you are capturing something to beautify a water or the air. So if you think about it, energy and environment, they go hand in hand with a sustainability mission. So we work on how do you purify water? How do you capture water from air under dry conditions to convert it into drinking water? How do you capture carbon dioxide to minimize the climate change issues? But also we don't stop there. How can you take that carbon dioxide and actually convert it to something useful for humanity instead of just dumping it down the ground? How can we protect soldiers from toxic chemicals such as nerve agents? And once we know how to do that, then how do you protect now our firefighters to give them better suits, better filters for their masks? And once you know how to do that, Then we go to an adjacent market. How can we use the same technology, because now become a little cheaper, to go into and protect our farmers who are spraying their fields with all that toxic chemicals in order for their vegetables and fruits to grow better and produce. So you could see all these things, in a way, they are connected without a lot of people thinking that they are connected.
MOFs have captivated many researchers for more than 25 years, yet your company, Numat, is the only ones out there that has successfully transitioned this research to commercial markets. So tell me about Numat's success in this space and any advice for others who are, kind of struggling to bring their technology to the marketplace.
I think the way when me and Ben Hernandez, my co-founder, really thought about not just going through business plan competitions, but really starting a company and hiring employees. The first thing is, what is your first market? And it has to be a market that is attainable. You have to have a product in 2 to 3 years at most, because your investors, they don't have the patience for 15, 20 years from the beginning. And also, you want to show that your technology is capable of addressing an issue, and you need to go after a market that it's high value. You are a small company. You cannot be producing thousands and hundreds of thousands of metric tons. You need to be able to, produce enough to address a market. And that's why we went after the electronic industry, because they pay a lot for what you have if you could give it to them in a safer way to package these toxic gases for them. But at the same time, you don't need to make huge amounts. So that was our first market. The second thing, it's important that you go and you hire the right people. Surrounding yourself with people who are smarter than you, but from a diverse backgrounds. What I mean by that, engineers, chemists, the right financial people, and be able to capture those smart people and put them all together in one place. That's what differentiates Numat from a lot of companies. If I went and I hired just all chemists, and we went after the hydrogen storage or the CO2 capture problem from day one, Numat would be bankrupt. We would not be talking about Numat right now. Then our second market went into the defense application, which it needs much larger market, more complex market, a more sophisticated material is needed. But that came by hiring people who are now have expertise and pay them well, retain them, and make the culture of the company a culture that people want to come to and stay. And that's not giving in a startup company. But me and Ben, we decided you don't just go hire people to fill a position. We took our time for every hire until we found the right person, even when the board will tell you why this position has not been filled yet. You cannot just fill it with anybody who applies. You have to fill it with the right people that have the right conviction, and more importantly, that they fit the culture that you're trying to build.
And now your company is part of this really thriving biotech industry that's emerging in Chicago. You have, 80 employees in Humboldt Park? Is that right?
80 and counting. We just hired a couple maybe just in the last week or so, and more to come.
What a fantastic success story in nanotechnology.
On that note, in August, you published a paper in Nature Materials titled Transitioning Metal Organic Frameworks from the Laboratory to Market Through Applied Research. So what are the next steps for MOFs in commercial applications, and what new industries do you see them impacting in the near future?
Yeah, we talked about a couple industries. I think right now MOFs are in a position perfectly to tackle really even more complex problems and much larger scale. And if you notice, the authors on that paper from Numat and the big company BASF. And why we jointly wrote that project? Because, BASF is a company that knows how to make things at thousands of metric tons, and Numat knows how to drive things very quickly and faster. And we wanted to give the audience the perspective of a thriving smaller company and a successful giant company, and how they actually get to see the future of these materials. So the next, I believe it's going to be carbon capture, because this is going to be one of the biggest problems that this world is going to face to our children, our grandchildren. It's not going away. By hearing people saying, it's normal, this is natural, it's not. If you just see how, the temperatures, how many days over 90 degrees, droughts, fires, it's crazy. So we have to address that. And I think MOFs are poised, and they are right now the right time for them to go and address that. And actually, there is many companies making big investments, making devices to go tackle CO2 capture and sequestration. The second thing, I believe MOFs will be used in the next few years, is be able to capture water in areas that you would think there is no water. Because I am a believer in the next 20, 30 years, wars would be fought over water, not over oil. If you go into areas where right now the wars are fought over oil, similar areas, they will be struggling to have access to clean water. If you don't have the energy to desalinate and you live far away from any sources of water, what are you going to do? And here, MOFs will have the ability to capture water from air, even down to low humidity, such as 10% or lower. That's like Mojave Desert type of humidity, and be able to convert that into a drinking water. Wouldn't that be a beautiful thing to do? You could be in the Sahara Desert and have a solar panel.
Wow.
And looks like an air conditioner unit on the top of your house, and be able to power that device to get you water without having to think where the water came from. That to me, amazing. Not many materials out there have the ability to do that, but I am a believer that MOFs will be the materials to solve these problems.
Sounds like something from Star Wars, like what they were doing in Tatooine, where they're moisture evaporators. That's what their farm does. That's kind of crazy.
Yeah, it's real. It's really real. And right now, there is actually startup companies. There is companies out there that they have already devices, and those devices are enabled by metal organic framework for water harvesting.
You have the new facility. Is that NewMat, or is that going to be something different?
We have two facilities will be open by the end of the year. One of them, it's actually already open. It's in Humboldt Park. So our first manufacturing campus has opened, and we moved to it in March 15th of 2024. And that's where we do all our R&D, and we do all our post-material making and product manufacturing. In Q4 of this year and early next year, we'll have our second facility is in Wisconsin. It will be opened, and that's where we'll actually make hundreds of metric tons of metal organic frameworks to be shipped to Humboldt Park facility for the processing and final product making. Terminal is the location. And the interesting thing about the terminal, it was built like 1906, 1907. Beautiful old Chicago campus. And the 100th patent of Nikola Tesla was done in that facility, which is how you convert steam into electricity. And that's where they discovered how do you make the front lights of trains and have the ability for trains to travel at night. Then in the 90s, it was, abandoned. And when the real estate agent took us there, and it was a place where stolen cars were, ripped apart, broken glass, you had to see beyond that. You had to see what that facility could be. And right now, when you go visit the facility, you have the beautiful outside, beautiful old Chicago. When you come inside, you see beautiful brand new facilities. But at the same time, since the inception of that facility until now, new technologies have been made into reality in that facility. And that's something, it was captivating. And that's why we decided to actually move into such a facility and not look at it. Look how disgusting this location.
Yeah, that's like hollow ground when it comes to science and technology, to have a history like that right in the heart of a Chicago neighborhood. That's incredible. We've talked on previous episodes about how Chicago really is becoming a destination for people who want to work in not only biomedical science, but nanotechnology. And just tell me about your motivation to keep things in a Chicago neighborhood to grow your company there.
I am a professor at Northwestern University, and the company was established in Illinois. We started in Skokie, and the founders, we both believe that this company will always be an Illinois-based company. And when we start looking at locations, the city of Chicago is a beautiful city with a fantastic ecosystem for companies. But beyond that, as I said, the location itself was just a place that you couldn't let go, thinking about that the type of discoveries been done and how many of these discoveries helped humanity. People take that for granted, being able to move trains at night instead of only during the daytime. That's what moved this country. That's what accelerated the industries in this country. And right now, Numat is building on that trajectory into building the next generation materials and taking nanotechnology beyond where it is right now.
Nanotechnology has clearly the potential to dramatically improve the lives of people across the world, and it is something that you try to impart on your students. So tell me more about how you inspire your students to consider the societal and environmental impacts of their work.
Honestly, I don't have to do that because they do that by themselves. They join my group because of that. When I go talk to students during recruiting weekend, we talk about is not just the materials themselves. We talk about why these materials are important and what kind of applications we got to go after and what's the implication of these applications on humanity. And that's why they really come and join my group. I tell them we don't make things because they are cute. If they don't have a function and the function is to make this world better when you leave it than when you entered it, then we're not doing our work as scientists.
I think that your students call themselves FAR homies. Is that right?
That's right. We are the FAR homies.
It sounds like a great group. I want to shift gears a little bit. We've talked a lot about MOFs, but I want you to look into your crystal ball at perhaps the next most promising big thing in nanotechnology. Is there anything else out there that you are following that you would like the listeners to be aware of?
Absolutely. I mean, think about, in the next few years when we could actually come up with a vaccine for cancer, not to be able to, come with medication and treatments for cancer itself, but, protect people from actually getting it. Or if they get it because they are exposed to impurities in water or exposed to impurities in the air, how can we eliminate and remove these impurities from the water and remove impurities from the air? How can we come up with a customizable or personalized medicine that it's not just one medication fits all, but you get the medication that you need as an Erin, as a Seth, as an Omar, not generate one medication and say this is going to be for everyone who has these symptoms. That's where nanotechnology in the next 15, 20 years will be. I think nanotechnology is at a beautiful place right now, but we just scratched the surface. It's the most yet to come from what we could see from these tiny things that we cannot even see.
So in your work with MOFs and nanotechnology, what has been the most surprising or, let's say, unexpected discovery that you've encountered?
As we always talk about programmability and predictability and all that good stuff, but honestly, sometimes serendipitous discoveries is just as exciting. And I would say recently, a couple of years ago, one of my students, her name is Sylvia, she's right now works for Dow Chemicals, discovered a new way of making these materials. Just to describe it in a way, nature does not like empty spaces. Nature, like if you have something, it will go and build something in it, likes density, it likes things dense. And Sylvia discovered a new mechanism to make materials the least dense possible and make nature drive it that way. And that was a serendipitous discovery that we didn't go to the board and draw it. However, she was a brilliant student who figured out that she discovered something more important than what she was trying to do. It's not just my lab alone. All labs around the world and every lab at Northwestern, we get those discoveries that excites us even more than the ones we drew on the board and we went to the lab and we made.
You've worked with colleagues from around the world to advance the nanotechnology field and research. How important is this international collaboration, this international community in advancing the future of nanotechnology?
We always say that science knows no borders, and I am a believer in that. And that's what makes Northwestern one of the best places to work, because collaboration is the hallmark of this place. Same thing, IAN, collaboration is the hallmark of IAN. And if you want to tackle really hard problems, and I hope we all do when we work at a place at Northwestern, you cannot do that on your own. You have to collaborate with people from different fields. I am a chemist, so I need to collaborate with engineers, with material scientists, with data scientists, with software engineers. That just if we want to do it in the US, then going internationally. People get trained in a different way. Depends where you come from. We get trained differently. We get to think about solving the problem differently. And sometimes different people are exposed to different environments. And because of that, we really need to go beyond our ecosystem at Northwestern or even ecosystem in the United States. We need to go beyond that. And if we want to drive hard science, we have to do this regardless who is telling us what we can and cannot do. Because as I said, if we want to drive science for humanity, we need to go beyond our bubble.
Yeah, diversity is so important. And I know that's something that you try to build within your own lab. You have a wonderful group of international students and American students, and it's a place where a lot of people want to be. So as we wrap up here today, is there anything you would like to leave our listeners with, whether it's about the future of your work or nanotechnology in general?
I think I want the listeners to know that, as I said before, we just really scratched the surface. And I hope they will keep track of what we do with nanotechnology around the world, but in particular what IAN is doing when it comes to nanotechnology. And, keep reading the news about what we do and what my colleagues do, because you'll be amazed when you think, wow, this is an amazing discovery. Just wait for another 6 months and another year. You'll find another one of my colleagues have even a bigger and more amazing discoveries to take us forward and actually go and solve big problems in environment, in energy, and in medicine as well.
Omar, congratulations on becoming the new chair of the Northwestern University Department of Chemistry. You began this 3-year term on September 1st, so what are your plans in this new leadership role?
It's an exciting time for me personally because I've been trusted by my colleagues, by the administration to take this role with the idea, how can we take this department from excellence to eminent? We are at a trajectory, and how can we now inject, steroids into this department and take it to the top of that hill. I am a believer. It takes few things to get there. One, our students and postdocs. We have amazing students and postdocs. Second to none, facilities. With the help of, work from Central, the International Institute of Nanotechnology, Northwestern, and many other institutes, we have the best shared facilities in the world. And nobody can argue against that. Then we have the best faculty. I am intimidated when I present in front of my colleagues. And be open to visitors, be welcoming to visitors from all around the world. Those are 4 important things. But the 5th and the most important thing is the staff. A department without the best staff to support the other 4 pillars, it cannot survive and thrive. And I believe we have some of the best staff in the world.
This is very exciting news, and they definitely picked a pioneering visionary for this. I'm excited to see what you're going to do, and I'm wishing you all the best in this role.
Thank you, and I look forward to many years working at IAN and in our departments, and I look forward to many years working with Seth.
Right back at you. Yeah.
Well, thank you so much, Dr. Omar Farha, for all of your insight today. We really appreciate it.
Thanks so much for listening. This podcast is brought to you by the International Institute for Nanotechnology at Northwestern University. Be sure to follow this show on Apple Podcasts or wherever you listen to podcasts, and be sure to give us a 5-star review.
For more information about IIN, go to our website, iinano.org/podcast.